Hi, I'm Dr. E, Ellen Stofan, and Dr. Z, Dr. Thomas Zurbuchen, and I would like to answer some of your questions. Let's see. It says, my 11-year-old space enthusiast wants to know, what does NASA want to accomplish on the moon when humans return there in the next few years?
I really want to answer that question in two parts. The first one is we want to create the capability not only to go to the moon, but going to Mars. Those technologies, together with the commercial and international partners that we work with, will bring us there in a way that we can turn around and move towards Mars. We've never done that, and we want to increase the sphere in which we can explore with humans. What an amazing thing. But there's a second part, and that is that we want to do science and exploration of the surface of the moon. There are interesting questions that we want to answer there about the age of the solar system, about the history of the Earth and its bombardment and so forth. Early in the Earth's history, we want to learn about water and many of the questions about this body that is our neighbor there in space. And those questions we want to answer with experiments that we're developing right now. Okay, I'll ask you a question. Did Mars or Venus host ancient watery environments conducive to early life? And is there evidence that life emerged?
You know, that's one of the things that has really driven some of our exploration of those two bodies. For Mars, the answer is definitely yes. You know, we've long known that Mars has channels carved by water across its surface. But all of our spacecraft have helped us hone in on the fact that Mars probably had surface liquid water as much as an ocean's worth from about 3.9 or so billion years ago to about 3.5 billion years. During that time, the conditions existed in which life could have arisen, and we're still trying to figure out, did life actually evolve on Mars or not? And with our next mission to Mars that's going to be launched this summer, we're going to be looking into that very question of, can we find more evidence that did something looking towards life actually evolve on Mars or not? So we have a lot of questions about that. Venus is actually an interesting story because back in the early 80s had a spacecraft that measured the isotopes of hydrogen in the atmosphere of Venus, which told us that Venus probably early in its history lost an ocean's worth of water. So it had a lot of water, but as Venus evolved, it lost that water. Some models suggest that Venus indeed could have had an ocean, but we want to go back to Venus and really measure the chemistry of the rocks on Venus, because that's what's going to help us answer that question.
Talking about places with potential life, let me ask one more question, which is, I'm interested if we ever go and send a real probe to Europa to see if there's really anything in that ocean under all that ice.
One of the things we want to do with the Europa Clipper mission is actually go look at where we think there are plumes of liquid that are erupting from that subsurface ocean out into space. And if we can analyze some of those materials that are coming out of the interior of Europa, look on the surface where the material from those erupting plumes would fall, we're hoping that we can understand more of the chemistry of that subsurface ocean. Eventually, obviously, what we would love to do is land on the surface of Europa where we could make better measurements and try to understand, could there be life in Europa's subsurface ocean? And scientists and technologists have even come up with concepts for spacecraft that could land on the surface and maybe melt their way through the ice to go and explore that subsurface ocean. But those missions are probably a couple decades out. This is a fun question for right now, and in fact, I was just thinking of doing this today. How would sourdough starter thrive in space? Do you know that one?
I'm actually interested what you came up with when you thought about that earlier today.
It's interesting because I've gone out to classrooms before and done an experiment with yeast to help kids understand the idea that different conditions on different planets can affect life. And so we've done an experiment where we put yeast in hot vinegar, and we put yeast in ice water that is super cold. We microwave it and then put it in water. And it's amazing. Actually, the yeast still is active. All those harsh conditions make it a little less active, so it bubbles a little less. But yeast actually only needs sugar and moisture and warmth to start activity. And so it doesn't really need oxygen. So I thought that was an interesting thing. I didn't realize it didn't need oxygen. I did think it needed oxygen.
And you know what's amazing is how general these principles are applicable throughout the universe. And actually going on a space station, where of course the astronauts have big cookies up there, is kind of one of those exciting experiments. There's many others.
Thanks so much. This has been really fun, and I can't wait to do our next episode of EZScience.